Thank you very much. Hi, everybody. Thanks for inviting me to the VuFind Summit. So my name is Hector Correa. Oops, I'm a software developer at Brown University, and I'm going to talk about what we're doing to index text in Chinese, Japanese, and Korean in Solr. Before I start, I should warn you that I do not speak Chinese, Japanese, or Korean. But the session is the work that I did with the help of others to index what is known as CJK text, Chinese, Japanese, and Korean text using Solr, even if you don't speak the language. So what I'm gonna talk about in the next 20 minutes is the problem that we were facing, and then how we're indexing CJK text now to get better results for searching. There will be time at the end for questions, but if you have questions as I'm going, feel free to put them in, especially if they are something that will help you understand better the rest of the session. You don't have to wait until the end. So the problem that we were facing is what is known as precision. When somebody will do a search in our catalog using, for example, this author name, Mojan, but using the Chinese characters, we have about 70 records in our catalog that are a good match for this. And we were giving the user something like 300. Precision is calculated as dividing how many correct results are divided by how many you gave to the user. And you can see that in our case, the precision is 0.24. And you can visualize the 72 versus 300. For every good result, we were giving the user 3 incorrect results. So this can be overwhelming for a user. They search for something and they get a lot of information that is not relevant. And this is another example, Yumiri. This is another author name in Chinese. If the user were to enter the 3 Chinese characters that I have highlighted, they will get more than 1,000 results, and we only have 15 records in the catalog that are a good match. You can see here, precision is getting very close to 0. And this is an extreme example. This is a title name for a book in Japanese, Fukuru no Hon. Same idea, we have about 11 records in our catalog that are a good match for this, and we will give the user 4,800 plus records. We might as well give them the entire catalog, right? I mean, this is a really bad user experience. The precision gets closer to 0. Now, when we look into this, the root of our problem was that we were using text general fields in Solr to index text in Chinese, Japanese, and Korean. And we have used text general before for many kind of text. Our catalog has records in English mostly, but also in Spanish and French, in Italian. And we have used text general for those languages, and the results have been okay. We have used specific fields like text in English for certain optimizations, but by and large, we were using text general for everything. And as I said, our results were okay. What we didn't know is that they were okay for certain languages, but not for others. In the case of Chinese, Japanese, and Korean, text general turns out that it's a horrible match. So let me show you what the problem looks like in real life. The slides that I'm gonna show you next, you can do the same step that I'm doing. If you go to Solr installation, you can pick any core. There's an analysis option. And in this analysis, you can enter a text. And when you enter the text, you can select what kind of field you would like to. Hello, everybody. Hello again, I guess. So I'm gonna try to pick up where I left off. I was mentioning that the root of our problem was we were using text general fields for indexing Chinese, Japanese, and Korean, and that was a really bad idea. So what I'm gonna show you next is how we went about discovering the problem. And this is the screen that I was showing before I cut off before, in which you can enter some text, in this case, for whom the bell tolls, and ask Solr to show you how this field will be stored if you store it in a text general field. And you will see here that it split the text in words, which is what you will expect. And then it runs it to some processing, in this case, stop words and then lowercase. That's where, even though they are uppercase each word, they are stored in the index as lowercase. This is what text general does. If I use text in English, for example, instead, you will notice that it runs the text through some processing. And in this case, it did drop the stop words for the English language, in this case, for and that. It also lowercase the text. And towards the end, if you notice, the word tolls was stored as toll. And that's because it's using the stem of the word. This is what allows Solr, when you search for something that was indexed as running, if you type runner, you might find it because Solr might actually store only the stem of the word, run. Now, what happens when we use text general to store text in Chinese characters? In this case, this is the word Ho Chi Minh, spelled with the Chinese character, you can see here. If I analyze this to text general, with text general, Solr split each character as its own token, and then it pretty much didn't do anything to them. Now remember, I don't speak Chinese, Japanese, or Korean, so I look at this and I thought, that looks okay. Turns out this is not okay. If you speak Chinese, Japanese, or Korean, you will notice that this is a horrible way of indexing the data. And now let's see what happens if instead of using text general for the same text, this is Ho Chi Minh, we analyze the text using the CJK, text CJK field that Solr provides out of the box. It will do the same thing. It will split it into 3 tokens. It runs it through some processing. But at the end, notice how it combined the characters back again. It's slightly different. It combines the first with the second with the third. This is what is known as bigrams. This CJK bigram filter, what it does, it combines the data again in 2 character sets. Turns out this is really important for Chinese, Japanese, and Korean languages. We didn't know that, and so this is what we're using these days to index our data. When I said that we were getting really a large number of results at the beginning, say 5,000 results for something that we expected 5 or 11 results, this is an example of that. In this case, I'm entering the text Ho Chi Minh on the left side. This is how a value will be indexed. And on the right, I'm entering a totally different text. You can see the text right here. This is the name of a book about Buddhist temples. And this is the word Ho Chi Minh. They have nothing related to each other if you speak Chinese. If you analyze this with text general, you will see how Solr believes that there are 2 matches. These 2 characters match in here, and that's why they're highlighted here. Solr considered this a match. This is where we were getting a very, very large number of matches for things that were not related. This is because we're using the text general field. If we run the same example, but in this case, we use text CJK, you will notice that it did what I showed before. It splits everything in individual tokens, and then it joins them in, using bigrams. And the same thing on the right side. And in this case, it doesn't detect any matches. This is what we will expect. Something to notice about the when you use text CJK is that Solr is smart enough to use bigrams to the part that makes sense. In this case, I'm indexing some text, Ho Chi Minh, plus some words in English. And notice how Solr used bigrams for the Chinese characters, but not for the words that were spelled using the Latin alphabet. So you can mix and match, and Solr will do the right thing as far as bigrams is concerned. Now, this concept of bigrams, this is something that exists in information retrieval and research. This is not something that Solr invented. And it is just plainly, if you take this text, you index A and B, B and C, and C and D. That's what bigrams are. Oops, I just changed them here. And this has proven to be good for Chinese language. And it's also a very simple algorithm, which means Solr can implement this relatively fast with very little memory and without being hard on the CPU. And it also doesn't need to do any lookups to dictionaries or anything like that. It just takes the text that you enter takes the text that you enter and splits it into bigrams. If you look at the documentation in Solr for the CJK bigram filter, you'll see that it just forms bigrams overlapping two character sequences. That's all it does. It has a few options that you can tune to configure whether you want bigrams for certain alphabet sets but not for others. We didn't do any tuning. We're using the CJK field as is. But if you implement this into your Solr, I will suggest you look into this documentation. There are some institutions that are using some of these configurations to get a better control of how text in CJK is indexed. Okay, so now that we know what the problem is, what did we do to fix the problem in our index? What we did is, so we're a library in the United States. We use MARC to store our data. I don't know how common this is outside of the United States. But in MARC, data is stored in fields, like in this case, the field 100 includes the author name. And this is one sample record. And the author in this case is Lin Quan Son. You can read the text right here. One thing that MARC does is that if a field has a subfield of 6 with a value of 880, it tells us that down here, there is another field that has the same value, the author, but using the original script. So in this case, this is how we spell Lin Quan Son in English, but in Chinese, this is how it is spelled. That information exists in our MARC records. So what we're doing now is when we index our data, we already have fields, for example, for the title, for the author, and we're keeping those as text general, and we store in there the titles and authors using the Latin alphabet. But we created separate fields, title txt CJK and author txt CJK, that for storing the values that are in Chinese, Japanese, and Korean languages. So in the previous example, we have a field author txt that stores Lin Quan Son. This is our original text general field. And we created a separate field, author txt CJK, where we store the word using the Chinese characters. Our discovery is built with Ruby. We use Traject to index our MARC files into Solr. So I'm not going to bore you with the details of that. But what I wanted to show you is that we have a function that we say, hey, extract MARC from these fields. And there's an option in Traject in which can tell it, I want only the alternate scripts. This means those values that are on the 880 for the author. And we store that into a separate field. So that's what we had to do to index our data slightly different. So now we have two fields. We have one field for the author using the Latin alphabet and another field for the author using the Chinese, Japanese, or Korean characters. Now we need to decide which field are we going to use for searching, right? If the user enters something like I'm showing right here in this screenshot, we would like to use the author txt CJK field because these are Chinese characters. But if the user enters Lin Quan Son, we would like to search on the author txt. Turns out there was a really easy and sneaky solution for this problem. We're using a regular expression. Regular expression support this /p kind of expression in which you can tell it, is there any character that matches this character set, the Han character set? Han is used for Chinese characters. Katana and hiragana is used for Japanese character sets, Japanese characters, and Hangul for Korean. So this is how we're supporting Chinese, Japanese, and Korean. So our code says if there's a regex, if the regex match, we're going to issue a search against the author txt CJK field in Solr. If there is no match, then we're going to use the author txt field. I am not a PHP developer, but I understand this works in PHP 7 as well. This is the extent of my PHP knowledge. But if you run this example, and the slides will be available, you can do a regex match. Notice I'm saying Lin Quan Son, this is the Latin alphabet. Are there any characters in the and Unicode script, and it will return 0. But the same expression, passing it the link console name in the Chinese characters, will return 3. So we did all this work. Did it work? Did it make any difference? It did, right? The results for us were night and day. Now, when the user search for Mojan, for example, but using the Chinese characters, remember how we were getting 300 results, but we expected 72. Now we're getting 56. And it turns out this 56 is actually the accurate number instead of 72. But I left the table just the same to show you how the changes look to us. This one, Jumiri, same thing, it's an author name. We were getting 1,000 results. Now we're getting 14, where we expected 15. So the precision is very close to 1. This is what we want. So let me, if I show you this search, everybody can see my browser still, right? I hope that's yes. A yes.
Yes.
Oh, great, thank you. So this is running an author using the character for Jumiri, you can see here, and I'm getting 14 results. And if you look at the result, you're gonna see that they are indeed for Jumiri. This is the author name. Something that we did when we implemented this solution, we weren't sure how good our detection of CJK characters was gonna be with the regex. So we displayed this little information icon. This is mostly for us, the developers, that tells us, hey, we're using CJK characters, fields in this case, because we detected CJK characters. And we have an option to disable it, which is really good for demos like today. So if I disable the feature, this is what a user was getting before we make our changes. This is without using the CJK fields. If you can see, it returns 1,700 results. This is totally not what the user will expect. So, but using the correct fields indexed and using CJK logic, now we get the results that the user will expect. And the same here, if I do a search by title, this is a search by title with those Japanese characters in this case, and we're getting 12 results, and these are the expected results in our case. So a few things before I wrap up. We're using Solr 7.5, but there is a bug in certain versions of Solr in which when Solr tries to create the bigrams, it can run into an exponential expansion of the query. And that's really bad, especially if you have large sets of text. For example, if you're indexing an abstract, more than a title, for example, something long like an abstract. This has been fixed in latest versions of Solr. Just make sure you check, you test your data, make sure you don't run into this issue. If you are going to implement this, take a look at what other institutions have done. I know that Stanford and Michigan in particular have done really robust CJK configurations. They have a large collection of materials in Chinese, Japanese, and Korean, so they have spent some time on that. Take a look what they have done. Another thing is that we are implementing the text CJK field as is. We didn't do any customizations, and we would like to do a few other things down the road. But one of the things that our implementation doesn't handle is the difference between Chinese simplified and Chinese traditional. In this case, this author, Shang Eilin, you can see on the left how it is spelled using simplified Chinese, and on the right how it's spelled using traditional Chinese. The first character is slightly different. This is not something that is handled by text CJK field that comes with Solr. A Chinese user will expect that regardless of how they search, we will give them the same results, We're not doing that right now. That's something that we still need to work on. And lastly, as I said, I don't speak Chinese, Japanese, or Korean. Many people help me with this process, from identifying the problem. In a previous conference, somebody mentioned that they were doing optimization for CJK, and I asked why. And then we learned that we have a big problem. And also people at Brown helped me document the problem, implement it, test it. And I'm going to include the slides. I'm going to send the slides. These are some of the references that I'm including in the slides. If you are going to implement this, I highly recommend reading some of these blog posts. In particular, Naomi Duche's post, she has a series of 11 posts in which she talks about how they did it in Stanford. That is very insightful. So I recommend those. And that's all I have. I'm ready for if there are any questions. I see a question in the Q&A. And this is the link to the slides, and you can contact me by email or by Twitter if you have questions after the conference that we don't get to cover today. So I see 2 questions. What is the advantage of our own CJK fields? We use language agnostic fields. So we don't need to identify the character of a query. We found, because we were using text general, we were not considering the CJK Bigram factory. I see here in the question that you are using the Bigram filter factory. So maybe that's a better approach, just one single field that accounts for the rules for both. That's not what we did. It's probably another way of approaching the problem. Another question, can you say something about other language specific factories? Unfortunately, no, I cannot say anything about these other filters for Solr. I know that there are other implementations within Solr to handle Chinese, but I haven't tested them. I haven't played with them. We use the text CJK field as is, and we got order of magnitude improvement, and that's where we stop. We would like to do more work into this, and probably we will look into these other tokenizers, but we haven't. So sorry, I cannot help there.
Thank you very much, Hector. Sorry.
Well, thank you for inviting me. I'm glad I was able to stay online this second time around.
We're very happy that you managed to come back again and resume your presentation. I think there's even another question just now, right?
Oh, yeah.
I'd also like to line up
in the 100. Are you using CJK in the 100 fields and 100 for Roman script, or the opposite? We're using the 100 fields to grab the Roman script, and then if there is a 880, that's what we use for the alternate script. So if I show the record again, maybe it's really clear. I'm still sharing my screen, right? Yes, I am. So this is a record. The field 100 has the name in the Roman alphabet, and if the subfield 6 points to an 880, man, that's like a tongue twister, then we go to the 880 and we look to see, is this value in Chinese, Japanese, or Korean? And if it is, that's what we store in our CJK fields. Did that answer the question? Oh.
So if I can ask a quick question, it looks like as you've implemented here, you're kind of searching one field at a time, but have you had any situations where you needed to use this in combination with Dismax to do cross-field searching? Like, how do you handle just a generalized keyword search for CJK independent of, author or title, etc.?
I'm glad you asked. So I only show field by field, but we do support, like for example, I still have this field here, and this is a title search by Foucault on Monjon, I believe. We do support this. You can select all fields. And in this case, if it detects that you're using CJK characters, it will search into our author CJK and our title CJK, but only on those 2 fields. But we're using edis max, and we can give them, we can boost the fields, we can do everything that we do, but we just use a different set of fields. Did I answer the question?
It does. I definitely would be interested to see how this approach compared against just adding the CJK Bigram factory to the text general field to see if that gets you the same improvement, but without limiting you to only searching the CJK text without everything else.
Right, and I mean, you're the second person that asked the same question, so I wonder how it works. We didn't even know there was a CJK Bigram filter, so we started from zero. So maybe just adding the CJK Bigram filter to an existing field is good enough, given that it handles relatively well mixing and matching CJK characters with the Latin alphabet. So it's possible that it will work. I really didn't